Dampening. Oscillating systems encounter opposition to motion in the form of friction or frictional resistance, and friction serves to limit velocity. Because of frictional resistance, vibratory motion does not continue indefinitely. The amplitude of vibration of the mass diminishes over time, and the vibrations are damped. The swing in the park, because of frictional resistance, the amplitude of each successive excursion, or its displacement, is slightly less than the amplitude of the previous excursion. Friction limits velocity, amplitude of vibration is diminished over time, and vibrations are damped. In simple harmonic motion, the dampening varies sinusoidally over time and is in phase with velocity. As velocity increases, kinetic energy is transformed to thermal energy, and the system is damped. Dampening occurs because of the resistance of the air medium and because of the internal friction within the vibrating system. As velocity increases, dampening increases because kinetic energy is transformed to thermal energy. Free vibrations do not continue indefinitely. Different vibrating systems are characterized by different amounts of dampening. In systems that are low damped, the vibration lasts for a relatively long time. In systems that are high damped, the vibrations are very brief and there is a steep decrement in the amplitude of vibration over time. In systems that are critically damped, the molecule turns to equilibrium very quickly. So A is an example of a lossless system which doesn't exist. There's no frictional resistance. In B, there's a low damped system, and C is a high damped system. As you can see, there's just one amplitude of excursion before the system dies out. So shock absorbers in the cars make a system nearly critically damped. If we didn't have them, you would be bouncing up and down with excessive oscillation if you drove over a pothole.